We're only given one statement, so we need to look at that statement. Segment AB perpendicular to CD, and see if we can't figure out what type of conclusion we can make. So look at your sheet where you have all those properties and definitions and theorems and figure out, okay, what conditions does that statement satisfy? Did you find the true conditional statement? If you need to pause and go look for it, that's fine. I think you're going to find that we're probably going to use definition of perpendicular lines. So what conclusion do they make? Well, they conclude that something forms a right angle. So looking at our picture, what angle are we talking about? Well, actually, by definition, it forms 4 right angles. So we can say that any one of those angles is a right angle, including, now we're going to think a little bit ahead. I mean, we could say all 4 if we wanted to, but I want to show measure of angle AMC, so A to M to C, equal to measure C to M to B. I want to show those two are the same measure. So I might focus in on those two and say those are right angles. I know by definition of perpendicular lines that angle AMC is a right angle. And you know what? I can use the same step because I'm using the same reasoning to make this next statement about the second angle. Angle CMB is also a right angle. And we could say that about all of the angles in that picture. But I'll start with just these two because I want to focus on those. If we needed more, or if we need more, we can go back and maybe add to it. But we'll start with these. Well, we use the law of detachment to satisfy those original, just that condition, so we can make the conclusion the right angle. Can you use the law of detachment with the next statement that we now have? That led us to knowing the right angles. Okay, what does that lead us to? What conditional statement or what conditions do the statements we have in 2 lead us to? If you're looking at your sheet and have already found it, or maybe you've done enough of these now that you know, it satisfies the conditions of the definition of a right angle. If something's a right angle, then we conclude something in that if-then statement we have. So if something's a right angle, we can conclude the measure equals 90. So we can do that for both of those. I can say the measure of angle AMC equals 90, and I can say the measure of angle CMB equals 90. And in 17, we had something close, and we used the transitive property, but it doesn't follow just the same way here. We don't have the conclusion of one being the conditions for the other. We don't have the second part of the equal sign equal in the first part, so it's not A and B, and then from that same B going to C. So we can't, it's not just right in the right order to use transitive property. One thing doesn't really just lead to the next, but we do have them 2 different angles, both equal to 90, so we can still replace, and it doesn't matter which one you use. Either way you'll get there. Sometimes it's quicker one way or the other, but let's just try it and see what happens. You can always erase if we need to. I'm just going to rewrite this equation. Measure of angle AMC equals 90. But instead of saying equals 90, what can I replace 90 with? What else equals 90? Well, besides AMC, measure of angle CMB also equals 90. Replacement rule. Actually, that's my final statement. If I had used the second one and replaced, I probably would have had it in a different order and used S little yp, that symmetric property of equality, to switch the order. If I needed to show they were congruent, I could have used definition of congruent angles to prove them congruent. But as it is, 4 steps, and that's what we wanted to show.